Today we'll see the introduction of stress life approach. It has got 11 units, starting with introduction, ascent curve, factors affecting endurance limit, factors affecting fatigue strength, effects of mean stress, effect of notch, fatigue life under constant amplitude loading, fatigue life under variable amplitude loading, minus rule, cycle counting techniques, and finally, the methodology for total fatigue life. A series of video will be posted in the LMS for each chapter to cover the entire Unit 1 syllabus. Now coming to the introduction part. In layman's language, when one does overwork or sits in front of system throughout the day, he or she feels tired or fatigued. Fortunately, in human beings, it is a recovery process. But in the case of metallic material, when it is subjected to cyclic or repeated loading, it starts degrading the mechanical properties from day one. To understand its significance, when structure is subjected to inaxial slowly the tensile load, the failure will occur to one cycle once it reaches the ultimate strength. But in fatigue, though the loads are very small, the mechanical degradation starts from day one, from first cycle, and it start inducing damages which are not recoverable process like human beings. And every repeated cycle, it accumulates the damage, and finally it reaches a critical condition where with small load, it leads to the catastrophic failure. To understand better, if a specimen is subject to tensile stress, with having 450 megapascal as the ultimate strength where the failure takes place, but if the load is applied repeatedly, 50% of the ultimate strength, it will take millions of cycles to fail. Now, this shows the typical failure of the crankshaft. One can see that you have a stress razor at the keyhole where the crack will initiate and propagate, and at the end it will fail with overload. Usually, the fatigue fracture surface will show the flat and telltale sign of benchmark or striation. To understand the fatigue, there are evaluated, categorized into different aspects. One is called mechanical fatigue, which occurs due to the stress or strain. Then, if there is a variation of temperature, that induces a thermal cycling. Then, your fatigue due to sonic or acoustic happens due to induction of vibration caused by intense aerodynamic and acoustic pressure fields. For example, structures exposed to jet engine and intakes and exhaust. Then corrosion fatigue in the presence of corrosive environment like offshore structures, ships, aircraft in Navy. Then fatigue that occurs due to the relative displacement between two plates. And finally, the vibration fatigue that occurs due to the vibration of equipment during operation like a compressor or rotating equipment. To understand what exactly fatigue cycle is, this gives an example of simple constant loading, which is repeated continuously, and it is defined at a different parameter like stress range, stress amplitude, mean stress, stress ratio, and amplitude ratio. So based on any two parameters, one can describe the cyclic load. Thank you.